Hello, it's Mrs. Walsh, and I'm going to go through the 7.1 note sheet with you, the fundamental property of rational expressions. There are three main objectives on this note sheet. Let's first start out with what a rational expression is. It is an expression in the form P divided by Q, where P and Q are polynomials. And in this polynomial, Q cannot equal 0. We'll talk more about that later. So basically, we can think about a rational expression as just a ratio of two polynomials. And you might recall that a ratio is often written as a fraction. So we're going to see a lot of fractions that have both a polynomial in the numerator and in the denominator. So our first objective is to just rationalize rational expressions. So in example 1, we want to evaluate the rational expression here, both when x equals 1, here's our rational expression, when x equals 1 and when x equals -2. All right, so for part A, we're just going to substitute 1 in for x. So 2 times 1 minus 4 over 3 times 1 plus 6. Evaluating the numerator, we have 2 minus 4. The denominator, I have 3 plus 6. We're following the order of operations. So that gives me -2 over 9. That's the value of my expression. In part B, we're looking at when x equals -2. So I'm going to go back and plug in -2 for x. So that will give me 2 times -2 minus 4 in the numerator, 3 times -2 plus 6 in the denominator. Following the order of operations, that gives me -4 minus 4 on the top, -6 plus 6 on the bottom. This is -8, and this is 0. So I have -8 divided by 0. If you try that on your calculator, it will say error. It is because we can't divide by 0, so we say that this is undefined. Okay, it's not 0, it is undefined. So that leads us into our next objective. And the question is, are there any values that x cannot be in the polynomial in example 1? So what we have to be careful of is that the denominator, the bottom of our fraction, cannot equal, let me erase that, cannot equal 0. It's fine if the top equals 0, but the denominator, the bottom, can't be 0 because we can't divide by 0. It's impossible. The rational expression is undefined if this happens. It is undefined if the denominator equals 0. Equals 0. All right, so objective 2, we want to find the values of the variable for which the expression is undefined. All right, so again, we said that the denominator can't be 0, so I'm really focused in on my denominator. So what value, back to the original slide, so x minus 5 is 0, so that means if x equals 5, the expression is undefined. So I say x cannot equal 5. I'm going to let you do part B by yourself and part D. You can get the answers from Canvas on the filled-in note sheet, but let's go through part C together. So again, I'm focused on what is going to make my denominator equal to 0. So this is a trinomial. I'm going to factor this. This factors into r plus 4 times r plus 2 by whatever methods you use to factor. So I want to know what's going to make this equal to 0. So I set r plus 4 equal to 0. Using your 0 product property, one of these two guys has to be 0. So if I subtract 4 from this side, I would get r is -4. So r cannot be -4, otherwise my denominator is going to be 0. Here, if I subtract 2 from both sides, I would get r is equal to -2. So that means r can't be -2, otherwise my denominator is going to be equal to 0. So these are the values of the variable for which the rational expression would be undefined. On to the back side of the note sheet, let's talk about an expression, a rational expression being in lowest terms. A rational expression is considered in lowest terms if the greatest common factor of the numerator and denominator is 1. So if there is any other GCF they have in common, we need to cancel them out. Here your sheet looks a little bit different than mine. This should say if P over Q is a rational expression, and K represents a polynomial, where K, this is supposed to say K, does not equal 0, then P times K over Q times K, and this you already have written on your sheet, equals P over Q. You can cancel out the common factors of K. Now when you're simplifying rational expressions, this is really, really important. You can cancel common factors but not common terms. Really important. So let's talk about the difference quickly between factors and terms. The example you have written here already is x times y divided by 2x. Notice these variables are being multiplied together. They're written as a product. That means that they are factors. Factors are written as a product, as a multiplication problem. So you should feel free to go ahead and cancel. Please cancel with the smiley face. So in this case, I can cancel out my common factors, which are x on the top and x on the bottom. So I cancel them out, leaving me with y on the top and 2 on the bottom. So the simplified expression is y over 2 in this case. In the second example that you have written, it is x plus y over x minus 2. Notice these variables are being added and subtracted. Therefore, they are terms. If we remember that terms are separated by addition and subtraction signs. So you cannot cancel the terms. So please don't be tempted to cancel out this x and this x. They're not factors. They're not written as a multiplication problem. We've got addition and subtraction going on, and you cannot cancel those terms. So there's no GCF here. This is as simplified as we can get. So the third and final objective of this note sheet is to write rational expressions in lowest terms. So I'm going to go through examples A and C with you, and you can find B and D in the filled-in note sheet on Canvas. So in example A, we want to find a GCF. So if we look at the numerator and the denominator, you should notice that our GCF is 2, because 2 divides both 14 and 2, and I have a k squared in the denominator, a k squared in the numerator, k cubed in the denominator, so I take the lower power, k squared. So 2k squared is my GCF. So I factor that from the numerator. If I divide out 2k squared on the top, that would leave me with 7. If I divide out 2k squared in the denominator, that would leave me with k. This is written in factored form. Look at this is being multiplied here and here. So these here are common factors, and I should cancel them out. So my answer to part A is 7 divided by k. If I go to part C, I notice that there's a common factor in my numerator. So I'm going to factor both the numerator and the denominator separately. If I take out 2, my common factor, I'm left with y plus 2. In my denominator, I notice there's a GCF of 2, leaving me with y squared minus 4. I hope this looks familiar to you. I have a perfect square minus another perfect square. Yes, that's the difference of squares. So I further factor my denominator into y plus 2, y minus 2. Remember how we took the square root of y squared and the square root of 4? These two numbers become my factors. One gets a plus sign, one gets a minus. So just rewriting the top here, notice now everything is written in factored form, written as a product. So I can cancel common factors. The 2's cancel. This whole factor in parentheses, y plus 2, cancels with this whole factor of y plus 2. Leaving me what in the numerator? Yep, you got to hold the place with a 1. And then in the denominator, y minus 2. And that's my simplified answer for part C. And lastly, the example on the bottom asks is 6 plus x over 4x in lowest terms. What do you think? The answer is yes, it is in lowest terms. Please don't be tempted to cancel this x with this x. I know it's tempting. This is a term. Check this out. These are being added together. You cannot cancel a term. Even though this is a factor, you can't cancel a term and a factor. You need to cancel factors only, not terms. So one more time, let's just write, do not cancel terms. Do not. Just don't do it. Thanks, guys.